Okay, thank you everyone for being here. We're going to have a session, both sort of a presentation overview session and also an open discussion around the work that we've been doing at Linaro and with the community the last year and a half or so on single zImage. Also, we're referring to these days as the multi-platform kernel that seems to have replaced the nomenclature as in the community and sort of within Linaro. So I'm Deepak Saxena. I lead the kernel team here at Linaro, and on Hangout we've got Arne Bergman, who's the maintainer, co-maintainer of the ARM SoC tree, and around sort of in this little circle we've got.
Shall I introduce? I'm Linus Valet from from kernel working group or ST Ericsson landing team or however UX 500 maintainer.
I'm John Masters. I run the ARM team at Red Hat.
Olaf Johansson, I'm the co-maintainer of ARM SoC with Arndt.
Can we have a microphone next to you?
Oh, really? Okay. I'm Nicholas Spider. I'm working with ARM and on ARM in different areas right now.
I'm Rob Herring. I maintain Calzada Highbank platform and co-maintain device tree and clean up ARM stuff in my spare time.
When you should be sleeping, you're cleaning up ARM stuff, just for the fun of it.
Basically.
Yeah. The goal of the session here is to kind of give an overview of what we've done, where we're at, and where we're going with this work, both at Linaro, within the community, maybe with some of our partners, as we sort of finish up the base work of getting the kernel running. What do we need to do also on top of the kernel to be able to actually have full distros sort of booting across the multi-platform kernel? Arne, do you want to start with kind of giving a status update and where things are at right now?
Okay, can do that. I haven't really prepared much. So I think last time I counted, we have something like 12 platforms enabled for multi-platform in the kernel now. The last addition that we just merged in 3.9 was finally the OMAP support. So we can now have OMAP included in multi-platform. In the previous kernel, in 3.8, we were adding IMX, which was also a pretty big thing. And then we have a lot of smaller platforms, including basically any platform that was merged over the last year. They're all multi-platform capable. During this week, I've been looking at the Exynos multi-platform kernel, and work has been going on that for a long time. And I'm much more optimistic now. We have a set of patches to clean up the header files now. I think the largest missing piece is the common clock code for Exynos now, and Thomas Abraham is working on that, and he probably has a better idea of what the status on that is. Once we have done Exynos, we basically have covered all the Linaro platforms. Linus might want to comment on the status of UX 500 for that, but I think we're also pretty good on that for 3.10.
Yeah, that will be fixed for 3.10.
Okay, great. So for 3.10, it looks like all the Linaro platforms that are upstream in the kernel are also multi-platform capable, which is, I think, a really good achievement. There is one bug that is preventing us from running some of the platforms in 3.9 together, which is what Greg mentioned earlier in his keynote talk, the two patches that I really, really want to have included in 3.9 for USB that turned out to be broken. Without those patches, we can't actually build the Marvell platforms together with OMAP and the VIA Wonder Media platform. So you have to pick which one of those should support USB, and it can only be one of them. We also have been working on some of the older platforms as a hobby. That's been basically Linus pushing some of that. I've been looking at the ST Spear code, and there are a few others that I might want to just do while because they're easy to do. We should also have the ARM reference platforms at some point. So Linus has a patch for integrator. Versal Express was one of the first platforms anyway, and we'll probably get around to do the other two as well.
I sent a pull request for the nomadic today, and the integrator should be quite easy to fix as well. Then I have the versatile board. That one might actually be trickier, but yeah, we should fix that. Then there's the real view. I don't know anybody working on the real view if we want to convert all the reference platforms from ARM.
Yep. So I think people are still using real view, aren't they? Like there's a Cortex A9 real view and other things.
I think that's what Russell King has.
Okay. Right, for Samsung, there's an additional problem with the other platforms besides Exynos, and I'm not sure how we are progressing on that, because right now you have to pick which Samsung platform you want to use. So even if Exynos is multi-platform enabled and S5P becomes multi-platform enabled, you will still have to pick one of the two, I fear, until we do a lot more changes in the Samsung code. Another change that we just merged was the virtual platform, which is what we are now using for KVM and Zen, as far as I can tell. And I think we will remove that platform again in 3.10 and replace it with a default platform, basically making all members of the machine descriptor structure optional, and make sure that the virtual machines can use the defaults. And then we can just drop that machine type completely and basically do the same that we are doing on 64-bit ARM, where we don't have any machine descriptor and don't need anything in the platform. There's also been patches for the HiSilicon platform, and I think we're pretty close to having an empty platform directory for that one as well. So that we might need one or two pointers in the machine descriptor for that, but that's only because it's easier to do than the alternative, not because we couldn't do it otherwise. I think that's it from me for a brief overview. I don't know what you have on what you have planned for this session, Deepak.
So I've got a couple other things here. I kind of want to give people an overview of where we're at, so thank you for doing that. And I know that we've got some silicon vendors here who may still be working on code that they want to work on getting upstream, so have a place for them to ask questions if they want to. And so there was a couple of things on these notes I've got here that one of the things I think we still want to look into is also building without PCI I/O space support, and I think that work hasn't started yet, correct?
So this is actually work that I started 2 years ago, and I had patches 2 years ago that I never ever sent to the mailing list. And I put this on the list because I really want to revisit this. And if it's not me, then we need to have someone else doing this, because I think it's it would make life a lot easier for anyone looking into multi-platform kernels, because this is confusing to anyone who has a platform that does not have PCI, and it's always confusing what people are supposed to be doing there.
Mm-hmm. Okay. So the other thing in terms of status, I want to kind of give people an overview of an understanding of where we're going to go next with this within Linaro, in terms of supporting the community and where in the single zImage work. So as Aaron went, to kind of provide an overview, we've pretty much almost got one platform per member company booting, and several platforms that are not even Linaro member platforms. And our goal is basically by next Connect, which is in, well, I don't know if I can officially announce when and where, but it's in the summer, to have basically Linaro providing builds out of our CI loop system that have a single zImage binary that will let you basically run a distro, Ubuntu, maybe Android even, if we can play around a little bit with Android, on the Linaro platforms. So that's kind of our our goal over the next 6 months or so. So we've kind of got the baseline kernel bits in place. Now it's getting the userland bits in place. Because the last Connect we demoed taking a single SD card with U-boot and with a zImage, and the same zImage, and moving it between an IMX platform, a versatile platform, and booting it. The biggest challenge there was basically some of the boot scripts, making sure that boot scripts would make the right decision on the right platform. And I think that's where we're going to start seeing some issues, is as we actually try to boot on full distros on in these environments using a single kernel, we might run into some issues with drivers also that we may not have touched. We've basically touched, I think, within the work that the community has been doing, it's kind of like the core infrastructure drivers. So the I2C, the SPI, the GPIO, all those things. But there may be drivers sort of a level up that may still need to do some cleanup, and there may be drivers that are out of tree, and that's something that we're going to run into, especially sort of in the mobile market, as I think the member companies in here start actually trying to build Android phones using a later kernel where there's been all these cleanups in the tree, and they've got drivers that may still be depending on header files that are no longer there. So there's going to be a little bit of churn there, I think, the next year or so as we get these out-of-tree drivers updated and hopefully upstream in this process. John, I know you've been, representing a distro. You've been doing some work with, booting single zImage distro images.
Right.
Do you have any comments there?
Yeah, I always have comments. There's, it's not an island, right? It's not just me. There's a whole bunch of people behind Fedora ARM. One of those guys is Peter Robinson, who does a lot of work on the kernel package in Fedora ARM, and should be thanked for that. What Peter's doing right now is, taking the package that we have, and what we're trying to do is we're trying to move it into a world where we have the multi-platform kernel as the target that we're running on pretty much all the boards. And as we can drop kernel variants, as we can, drop the kernel high bank package and go to just kernel and have support for the multi-platform kernel, that's what we're trying to do. What tends to happen, though, is things blow up, and then people start pinging me and saying, here's a backtrace, or here's some weird thing. Can you go off and spend some all-night hackathon figuring out what went wrong? And the problem is people are not testing multi-platform kernels. The real problem is that, so right now, in Fedora, the problem we have is that we're tied to what x86 does, because it's a primary architecture, and there's a lot of weird explanations there. But the summary is 3.7 is what's is out there right now. We're forced to go to 3.8 on somebody else's schedule, just whenever the other architectures move to 3.8, and a lot of stuff isn't working. Because it worked at some point during the 3.8 cycle. At the end, it didn't on some particular platform, and we pick up the pieces. So the reality of multi-platform is that it's a good idea, but sadly, it's not getting the level of testing to keep a good user experience when we ship it out the door.
Is that actually a problem with multi-platform or just with the base platform underneath? Is multi-platform the criteria that breaks, or is it OMAP or high bank that breaks?
Okay, so I agree. It's a lot of it's just general stuff, but I do think that multi-platform kind of makes the situation worse because people are still building kernels that are for their board with their config. And they are not actually building multi-platform kernels with suitable configs that we can actually, and actually get the testing, right? So it may be a board that breaks, but I think if people would actually build multi-platform kernels and actually use those in the development, that would be a good thing. Now, there have been some things that we've picked up that were specific. So the errata issue is one of those where, we discovered that we basically have to turn off a lot of errata because, boot a kernel and, whether it might, it's not called quite the same thing on 32-bit, but effectively you may not be in a secure mode in which you can actually write to errata registers and fix up things. So you don't know for a multi-platform kernel, so you end up turning off errata. And there's a whole bunch of issues like this that are coming up that need work.
So I think, go ahead, Rob.
But I think that's somewhat expected. I mean, multi-platform only went in 3.7, and you get through one set of issues and move on to the next. And like errata, I don't think we're done with. For example, if there's runtime ones that have negative performance impacts, people with later revs of the core that aren't affected are going to want to have a runtime solution to turn those off.
So John, can you say how many kernels you still have in Fedora and how many you want to have in the long run once we get this all working?
Yeah, well, I can tell you in the longer run, I want to have 2, right? For 32-bit, I want to have an LPAU kernel and a non-LPAU kernel. I can tell you exactly how many kernel variants are still left today, because I actually can't remember off the top of my head. We are trying to kill as many of them as possible. There's a base kernel, there's an OMAP kernel, and then that's the main set for... I will give you the answer in just two minutes. So Deepak, carry on.
Well, so on the wiki I see PandaBoard, TrimSlice, BeagleBoard, GuruPlug, and HighBank, and Versal Express.
Right.
I don't actually understand why you have BeagleBoard and PandaBoard separately, because they should have been able to coexist for a long time.
Yeah, they're in the OMAP kernel. There's one OMAP kernel that covers both of those.
Okay, so it's okay.
They're just, yeah, so we link to different images just to make life easier. But, okay, so here's the list. So you've got kernel, kernel OMAP, and that is it now in the 3.9 RC1 kernel that is being built for Fedora 19 right now.
And there's still ARMv5 support, right?
There is separately still ARMv5 support, but we have announced that we are going to, actually I should clarify that, there is still v5 support for updates of Fedora 18 and Fedora 17, but in Fedora 19 there is no longer going to be, so going forward, there will be no more support for v5 in Fedora. So, and I want, what I want to do there is I want to get that kernel count down to just a kernel package and a kernel LPAE package, and for that to be the total. But like I say, we're already building a 3.9 RC1 kernel right now, and higher. There are revisions of this already even. We want to get a lot of testing going on an ongoing basis.
So what I'm hearing, I think, is that there's, testing is a big thing that needs to happen now around the single zImage work. So I think there's 2 things there. One is, from a Linaro perspective, we'll be working on bringing multi-platform into our CI loop and building multi-platform kernels and images, and work with you, John, and other distro vendors, figure out where the config options want to enable, and test those. The other idea that I'm having right now is, so when I was talking to Greg earlier, sometime this week, he made this comment of, you guys still have def configs? So what about the idea of, as platforms become enabled for multi-platform, removing the def configs from the upstream tree and only having a multi-platform config?
Yeah, we already have one, and
okay.
What I've been asking for is make sure that's a superset. That should be the superset config that boots on pretty much any hardware.
Okay.
Actually, one other thing with that, could people please turn on features that make that actually bootable on distributions? Because we need things like C group support. I made a joke earlier about the system call auditing, although we do need that. There's a whole bunch of stuff to turn off. All right.
Yeah, I think that's the distro joke. I think one of the challenges there, because you're going to say that, but then the mobile guys who are using Android are going to say, well, we don't want C groups and all this other stuff.
What about distro configs in there? We had this conversation before.
Oh, in the kernel?
Yeah.
I would say no to that, and yeah.
Okay, so, but where's the overlap there between I'm just going to configure this so that I can boot something and run BusyBox, or I can do something useful with it?
So one idea is, I don't know if John's here or not, but there's the config fragment work that John did, where you can have these fragments that have like these different configs you can sort of pull in at build time. I don't know if people will be open to having fragments in upstream that basically here's a fragment enabled, but it seems more of a distro thing, yeah, but it's more of the default. Well, you know, if we remove the def configs for the individual platforms and just have a multi-platform config, for the maintainers, for the developers, you know, for people when they start getting up, when they start developing in-house, they won't have this idea of, oh, there's this def config on my platform. There's just this one config that I work with.
Another thing, we're also moving towards a place where we can actually build and verify that RAN configs work. I mean, there's been a lot of work there's been a lot of low-hanging fruit, but we're reaching a point where actually doing 100 RAN configs will shake out real bugs now, not just silly stuff. So people should get better at doing those every now and then as well.
So I actually want to get to the point where we can boot an all yes config kernel. I'm not sure if that's realistic, but it would be really, really nice if we could do that and then have that as part of the CI loop, because when we just turn on all the options, then we have a pretty good chance of finding a bug where one driver breaks all the platforms that it's not working on.
Yeah, the one thing it doesn't find is missing dependencies, but yeah, it finds a lot of other stuff. We need both.
So the next step after that would be making RAN config work, given that you have some set of, like you can have a config fragment already in RAN config where you say, I want all these options turned on, but randomize all the other ones. And if we get that running, that would, of course, be awesome, but I think we're a long way from that.
I have a question about removing the def configs. Even if you make the SOCs multi-platform, ultimately for shipping products, people are not going to use the multi-platform configuration. So wouldn't it be interesting to still have the def configs that?
So on the ARM SOC level, I've said I'm okay with picking up one def config per platform. I'm okay with that because I build all of them quite often, and building 150 def configs it takes a while. So adding one per platform, I'm not going to turn away, but adding one per board, which we still have some cases of, is unfortunate. But also having the superset, the same thing with your reference platform. People base it on the reference platform, and they should just take away the stuff they don't need.
Right, so if you have a system that doesn't have a network interface, then you usually want to turn off all the network drivers and all network protocols. And the same thing you do with the board support. Like if you today start out with the OMAP dev config, you have support for a few dozen boards in there, and any one shipping a product would just turn off all the ones that he doesn't ship on.
Well, even then, the dev config, it's a default config. You're supposed to modify it for your device if you're shipping a product.
Right. It's sort of the distro thing. It's like it's as a product developer, as an integrator, that's part of the work you'll do is figure out what are the specific features we need, because you may also be tuning some of those features before you ship the product. So I think what I'm hearing all off is then you're okay with the idea of having a def config per SOC type, basically. That's like for multiple platforms from that, multiple boards from that SOC. So like an OMAP.
Today I am, yeah. It depends on, I mean, if we hit the stage where we merge a lot of platforms that essentially have no code, we might just want to have, the multi-platform def config for them too. Okay. But today I'm okay with it.
Okay.
Well, even if we have platforms that have no code under Arch ARM, each of them will probably have its own clock driver and its own pin control driver. So there's some reason why we would still want, why it might make sense to still have separate configurations for them. Or we might have a configuration option for the platform that turns on the specific drivers that are required, but no code under Arch ARM, right?
Yeah, and one other big important reason for having a def config or having all your drivers enabled in a def config is to get build coverage, because we have some platforms that don't have def configs and we find out they're broken because nobody's built them for 2 years. And if nobody's built them for 2 years, well, maybe we shouldn't have them in the kernel, but we have a case of that right now, right? So
yeah. I recently tried just building all the def configs and then looking at which files don't get touched, and there are hundreds of files in Arch ARM that never get built by any of the def configs.
Yep.
So one question for you, John, from a distro perspective. So you're going to be booting, you want the single kernel image and single basically package that you're going to ship. do you have a request of other drivers that might be modularized? Like, for example, like, you know, and also looking at the maintainers right now, can we modularize things like GPIO for all the platforms? Can we modularize all the different controllers for the platforms? And is that something from a distro perspective you want to see more things modularized so you can have just a really basic sort of architectural level kernel and then pull other things out of the initRD?
We go two ways on that. So you know, historically we would have a lot more modules, and then on x86 they kind of got to a point where they're like, well, you know, a lot of platforms end up with driver X, so just build that into the kernel. But it's still very modular on x86, right? And that mindset has transitioned over into the ARM space. So you know, we've had some pretty heated debates, which is kind of funny, about you know, whether we should build in the MMC interface support on Versatile Express into the kernel, or make that a module, even though we're booting it from that interface, right? But the default mindset would be that's loaded in the InterMFS, right, and it's a module. So in general, think that things can be modules is something we would like, although, you know, some things that are really fixed in the platform that we're just expecting to be there, that's a bad example, but there will be other good examples of things that is common IP that we would probably build in. But modules are good.
So I would actually like to go to the point where we have much more stuff as modules than we can have today, including things like clock drivers, interrupt controller drivers, and other things that are really absolutely needed for booting. But if we're able to put them into the initRD, then it might be a good idea to do so, because some of these drivers are quite big, and we have a lot of them, and the numbers are growing.
Yeah, I mean, putting on my Debian hat for a minute, more or less as John said, the more things we can modularize, the more we can have one standard setup that boots on more things, because, you know, with an initrd. So as soon as you assume an initrd, then basically maximal modularization becomes a good thing. And that's pretty much the way everyone's going. So the standard Debian config, you have to have an initrd now. So do we? Oh, wow, okay. Right, well, yeah, you kernel people can worry about that, but I mean, from a configuration point of view,
so the comment for those that didn't hear is that we only have 16 megs for modules in terms of virtual space. And Wiki says we need to fix that.
Well, are we anywhere near that yet? Maybe we are. He says it's a relocation problem. We need trampolines.
But do we have systems which really need 17 megabytes of modules loaded, except some crazy NVIDIA stuff?
Yeah, who has a 16 meg kernel today with static code?
No, we have 4 megs.
All the config, but you know.
So all the config is currently something on the order of 30 megabytes, but that's only because it turns off a few options.
And I could also see, I mean, if somebody wants to do an all mod config and just try loading all the modules as a test, but in reality, it's not really enough.
Right, in reality, you'll just be loading these specific modules for a platform. Yeah.
I think clock drivers won't happen because, at least on some platforms, you need to have to query the clock framework to find out what the clock frequency is for your timer, which is going to be hard. You can't really boot until initRD without a timer, I think.
Do you need the timer before the initRD? Is something I've wondered about. Because
you can't do context switch. Well, you can do context switching, but you don't have any kind of preemption if you do not have
true,
a timer.
Yeah. You're right. You do need a timer.
You can't have a Jiffy loop. So timers are actually quite important. If you have architected timers, but not all people have architected timers.
Console output without interrupts.
Yeah, console output without interrupts, maybe. But
so maybe that interrupt controllers and timers are nice to have as modules, but it's not something we'll. It's not something we'll push down as a requirement.
But you need clocks. You need clocks. In some cases, you need clocks to have timers, so clocks become required too.
Right.
I think we should.
Yeah, that's quite common.
We should be a little more pragmatic. It would be neat if it worked, but in reality, I mean.
Now, if it's a problem that we can put those things into separate segments and discard them after boot.
Yep.
If
We used to do that on PowerPC, and we dropped that at some point because it turned out not to be worth it.
The big thing on PowerPC is that you have what, 4 platforms, and we have how many? So we might have more stuff to discard on ARM.
That's true. Yeah, I think at the time we had something like 8 platforms on 32-bit.
Could you have a more general solution where you have modules built in, but then they're basically discarded after boot? So kind of a built-in module.
How big has the single zImage got? I mean, is it significantly fat as a result of sticking lots of stuff in, or is it much the same?
So it's one of our action items to go and kind of collect that data. We started some work on that, but it hasn't been completed. It's something
So the multi-platform zImage is about 7 megabytes currently. If you turn on IMX, and because IMX has a lot of dependencies that it pulls in, like all the baud files for IMX, we might get a little bit lower than that. If you actually build an all yes config kernel, as I said, you get around 30 megabytes. If you turn off the optimize for size option in an all yes config kernel, it doesn't actually link anymore at all, because the kernel grows over 32 megabytes and we hit a lot of bugs at that point.
An all yes config kernel is not practical. It's only for build purposes.
That's right, but it should build.
Well, it should build within the limits of the architecture. So if we're hitting that limit, I don't think we need to work around that, because in practice it's useless. You don't
Right.
put that kernel onto a device.
It's a good way to catch just build issues also. Any other, I have nothing else on the agenda, so just kind of open it up for other people to throw things out there. So Kevin's asking if anyone's looking at the platform-specific init data and whether we discard that, how we discard that after the system boots up.
It's the same basic problem as discarding some of the code.
Right. So are we looking at that right now or no?
I think we should, we or you or somebody should start looking at it. Yeah.
Okay, so that's an action to sort of get someone to look at that, discarding init data.
So the analysis that Raj did was actually that most of the platforms are really small in multi-platform kernels, and I don't think it's worth it. IMX was the only exception where we have really large amount of code. Like the kernel grows by about a third when you turn it on. Every other one was something like 10 kilobytes or 100 kilobytes, and it's not worth optimizing anything for that.
Yeah, I guess it's mostly data. It's pin max tables and hardware mod and stuff like that.
Right. The code not as much. Okay. Anything else from folks in the audience or the little circle here? Rob?
What about removing old non-DT board files?
So I'm going to let Arndt answer that one, but my thought on that's almost a per sub-architecture maintainer thing. But let Olaf answer that.
Can I answer? Because I don't work for Linaro. I think actually it's time to set a deadline and get some pressure going on this, because it's been whittled away, but nobody's, I mean, some platforms have been, a lot of platforms have been working on this for a long time, but nobody's really been pushing the last bit, and I think it's time to put a bit of pressure on it.
We did that on PowerPC as well, where we had we had both modes running in the kernel at the same time, and then at some point we had a cutoff date, and anyone who still wants to run that stuff, it's just a revert, but you know, you're going to need to move forward to the new model.
Agreed. And we've always said where it can be pragmatic and just move over to device tree. You can keep a bit of board code. Tegra did this, for example. They kept some board callouts to specific stuff, but time to get rid of, you know, A tags, machine description, board files.
So what that means is that we probably have to make whatever hardware Russell uses a priority to convert to device tree.
Yeah, which platforms? Which platforms people are actually using haven't been DT'd? Because obviously, when Debian tends to support the stuff people have actually got, and some of that can be quite old, like slugs is probably one of the older examples of things that are still in use, and dream plugs and things. And I'm just wondering if anyone's done any of that stuff, or that all still needs doing if we enter a DT-only world.
Right. And then do we have a community of people who can also update bootloaders as needed for some of those platforms?
Yeah, that's
right.
not.
And I think that's where I get a little worried.
Yeah, probably the cutoff should be ARM v6 and above.
Well, yeah.
Okay.
So there's a couple of factors, right? One is you can use appended DTB on a lot of these, the ones where you can replace a bootloader. There's also the whole thing, I mean, the hobbyist platforms, we can't really put pressure on. I think we should be more lenient on those. But this is Linaro, and I'm happy to put a bit more pressure on the Linaro platforms, to be honest.
Mm-hmm. And I think what Nico said, which was basically worry more about ARM v6 and above. So that could be the cutoff. Is anything ARM v6 or above, DT only, anything before that?
That's sort of been the spirit so far. If anybody wants to convert something older, that's awesome. We're happy to see it, like Kirkwood and all that. But it's not mandatory in the same way.
Anything that's in the multi-image is the media candidate.
Yep.
Well, we talked about this like a year ago, and I tried to push really hard for making multi-platform DT only, and a number of platform maintainers strongly disagreed. I don't think any of those that disagreed are in the room there. I know that for IMX, people really wanted to keep board files around for a longer time because they're, especially on the older IMX platforms, there are still users of boards that will not get converted anytime soon.
So this is where I don't have to have. I'm a friend of Linaro, but I don't have to listen to Freescale in the same way, right? I think we should just require them to do it. There's easy ways to convert over. We don't have to do a full conversion. I mean, it doesn't have to be all or nothing, but it needs to start moving over.
Oh, actually, on the DTB front, we're in this world where DTBs are supported, but still on some platforms, people are just not using them. So, we have a situation right now where, get a bug report with the Panda board where if you use a DTB, it fails to boot. If you don't, then it's okay.
We've seen that in Linaro where we had DTB enabled for a long time. It's like, oh, our builds weren't using DTBs.
So,
are builds using DTBs now? Yeah. Okay.
So if you have a cutoff date, you'll also kind of clean out the wash of making sure everybody's actually using a device tree blob as well at boot time. So.
Well, then there's real view, which no one has bothered to do.
Yeah, I think that if you cut off ARM v6, then I think you can forget about N810 and N800 and probably even N900, because I don't think all of those have been converted to device tree at all.
No, there is no plan for those anyways. I mean, so it's like
yeah.
Yeah. So
there's the Cavium platform, CNS 3XXX, which doesn't have any DT support, and it's ARM11. There's RealView, and very little else that is ARM v6 or above and does not have DT at all.
So on one slightly different topic, so I think we have enough discussion on that single zImage and all these errata stuff. So is there a constructive direction now that what we have decided on? The ARM erratas which affect multiple platforms.
So this is not something that, this is a new direction, I guess, that I'm proposing. So we already have legacy platforms where we can't update firmware. There's been talk about updating firmware to put stuff in. A lot of this legacy firmware where we can't update the firmware to put the workarounds in are also going to be platforms where we need to have an appended DTB for the same reason, because we can't update firmware. So can we wrap it? Should we just, in the same point, wrap the kernel with the errata stubs around it?
In the zImage?
Yeah.
I think doing in the zImage would.
Unfortunately, wrapping doesn't solve all problems because we have things like off mode, which reset your CPU and then the errata need to be applied again. So it also needs to be done inside the kernel. Fortunately, we already know at that point on which platform we are, so it's probably slightly easier, but still, it needs to be taken care of.
I think for the runtime, yeah, the runtime ones like that, we know what platform we're on. And you don't do off mode really, really early during boot, right?
Not that early, no. No, CPU idle needs to be awake.
Nico? You look like you want to talk.
No, no.
Okay.
What did you say? I mean,
So for the runtime stuff, the real problem is applying the erratas at boot time, right? Because we don't know what platform we're on yet, and we don't know how to apply them on the platform we're on. We used to have hard-coded if-defs essentially in the early boot code, right?
I think it's more than that, right? I mean, some of the erratas will just make CPU crash because you don't have access to certain registers, or maybe it will just work on some platform because it boots in a secure mode.
Yeah.
Some kernel boots in secure mode, whereas some other kernel doesn't. So
right.
And we have erratas merged into the kernel by knowing that these are going to fault on certain kernel, even though that errata is really applicable for all platforms out there. So and multi-platform today disables all those erratas to just get kernel booting, but your kernel is no longer safe and reliable actually with those erratas.
Yeah, so we've been saying two things, right? One is on platforms where you can update the bootloader and firmware, you should move them so that you apply those erratas on the bootloader and firmware for the initial boot stuff.
Okay.
What Peter was saying, there's still cases like when you power off and bring up a core again, you need to apply them. That's runtime, and it's late enough that you can know by then, by probing the platform, whether you need to do this, and you can do that at runtime. That can be easily solved. It's not as challenging.
Off mode is not big problem because anyway you do have some sleep code of your own where you can work around this. But it was mainly the boot part which I'm.
Yeah, so we have the option where we can't update firmware, right? There are platforms where we can't update firmware, and those are also going to be the platforms where we append DTB. So we already have to build a binary kernel image that's unique to that platform, assembling it from a multi-platform kernel and a specific DTB. And we can just take one more piece of code there, right? And apply the errata, have a stub of a boot wrapper.
So is that code will exist in kernel, or where is it? Or will it be out of tree?
Pass. Yeah, it's part of zImage, I guess, but that we should hash out. And that, honestly, we should not. It's a proposal. We can talk about it here, but it needs to be talked about on the mailing list and in public.
Yeah, but it has been. I mean, you look at multiple thread. It has been there on list for almost 2 years now. I mean, I can show you many threads. It has just been tossed every single time when it is discussed, actually.
So I think this sort of, I mean, one of the things that this has been coming up for me is it's sort of connected to the issue around early print K also. Is like we can't really tell what kind of platform we're on early on enough in the boot, right? Debug LL, right. Right, and then the decision, my understanding is it was kind of made, like Russell basically pushed back and said, we're just not going to do debug LL on multi-platform kernels? Generic debug LL, okay.
But you can build it for your platform if you want to.
Okay, now what was his reasoning for not trying to?
You need to be able to call it from like the first assembly instruction. You don't know what you're running on.
Okay.
Yeah, you don't.
Okay. Right. Okay.
So one other comment on the DT boot enforcement. We got to remember that they're still missing DT bindings for quite a few things. So part of this is maybe one of the areas that Linaro can help in is the platform maintainers themselves might not be the ones to create the DT bindings. They can help and say what the requirements are, but Linaro needs to enforce the bigger picture. And I'm particularly thinking of kind of PM related things. There's a lot of like power state and CPU idle state stuff that's missing from DT. There's no bindings. And so we need, that stuff is needed, and there's a few other areas that are still needed. We need bindings before you can force people to actually use them, right? So that's a good, I think that's a good area for Linaro to be making sure those definitions are moving along.
Jakob, are you taking action? Are you taking notes? So can you take an action down? I think something to do is to go sync up with you and other people on like what are the bindings that are missing. So if they're complex bindings that need to be developed, we can go put a resource to go look into that.
So we don't have to have bindings for everything. But let's get rid of timers and IRQ controllers, and get those converted over.
And yeah, that'll get rid of most of the board files, but there will still.
Well, there's a difference between bindings for a specific driver and bindings for a subsystem. And I think what we need to do in Linaro is make sure that every subsystem has a proper binding, like the power domain and all those things. We've done a lot of those. Yep. We just merged the DMA engine binding in 3.9 finally. What I think we cannot do in Linaro is put resources on to have bindings for every single device driver. That's not realistic.
I agree. Yeah.
We can provide infrastructure.
Slightly tangential, but I had a couple of discussions at ELC 2 weeks ago about with a couple of people who were there. They're not Linaro members, you know, some of the newcomers to ARM essentially, that are not new to device tree, and they started looking at the state of ARC-ARM boot DTS, and in general, I think it's time to start doing some cleanups, because we've merged a lot of bindings, we've merged a lot of device trees. It's sort of a little crazy in there, and it's a little untidy. File structure and stuff like that, of course, but also some of the device trees are a little interesting, some of them.
And some of them are missing. So I've been trying to debug this issue on Versatile Express, and then the reply I got was, sorry, QM Versatile Express. The reply I got was, well, why are you not using the RTSM DTB? And I said, well, is that in the upstream kernel? No. So people are using DTBs that are still not in the upstream kernel for various devices, and that needs fixing as well. So you know, I generally expect when I use a DTB in the DTB directory that it's actually, you know, that they're there.
So one comment really fast though. I know at this was last summer. There was talk of moving the DTB files out of the DTS files out of the source. Is that still like a long-term plan?
Still the plan.
Okay.
Yeah, I think there was a plan to just exactly do the opposite, move the DTS files outside the kernel.
We've had a talk about that with the Zen folks at dinner a couple of days ago. One of the things that there's a real practical reason for having them in the kernel tree, and that's just plain convenience. And for that reason, I kept saying I'm going to take them out, and then I pushed back. Oh, I don't want to do that yet. I don't want to cause people that much pain, and I don't want to take on the work yet. The Zen folks want to be able to use it, and they don't want to have to go to the kernel tree to use it. U-boot folks want to use it. They don't want to have to go to the kernel tree. So it may be that we just have to do that. The other thing that came up in that same conversation is a big problem that we have. I'm very happy how much documentation that we have, that the rule has been established that you do a new binding, you document it immediately. That's great. The problem is that there's disconnect between the documentation and what the actually DTB files say. There is lots, it's not a hard problem. The documentation could very easily be in the form of a schema. It requires someone to do the work to do a schema parser and move the documentation into that format and have DTC spit out warnings if the schema doesn't match. A DCC linter would be fantastic. I would love to get a person or a Google Summer of Code student or someone to take that project and run with it. Now, as for getting the DTBs out of the kernel, the idea that was tossed around is create a new repository, make that be a mirror of the stuff in the kernel, and run in parallel for a while, and then start requiring people to make submissions to the new repository, and then mirror the other way.
So I would endorse that. I don't want to ship any DTBs at all. I want the platforms to ship that. But unfortunately, sometimes we ship card images where we are forced to ship U-boot as well, which I also don't ever want to do. But the problem right now is because there's a disconnect, we should just make sure that we have a message about, you know, you have to have a DTB and it has to be up to date and it has to actually describe the hardware that you have. So that's not necessarily true today.
Yeah, and another big problem that I've heard from many people, and I know it's an issue, is the DTBs have been under a lot of churn, and it's requiring a new DTB with every new kernel. That won't last forever. I know it's painful, but I've seen it on PowerPC. It won't last forever.
But I think ARM it's a fire hose, right?
Yeah.
And on PowerPC, it sort of settled down on its own because there was like 2 teams working on it, and when they were done, they were done. And changing over into the mindset of DTB bindings being set in stone, being an ABI essentially, needs to be encouraged and imposed at some point eventually.
And I think we could possibly do that do the switch over at the same time when we require the multi-platform platforms to be DT only, because that that's the point where we can expect them to have a rather complete set of bindings for the drivers that are upstream, at least.
Have a complete set of bindings for the hardware that the device tree is describing, you mean, right?
That's hard to do for some of the platforms that don't have any public documentations and are maintained by hobbyists, for example.
Yeah. One thing that I talked about at ELC was a little bit about workflow for sub-maintainers and developers, adding bindings, converting drivers to device tree and things like that, where you don't have to merge the device tree update together with the driver. You don't have to. They can land separately, and things just come together when they land. And that's a mindset we need to switch over to sooner. Otherwise, moving over to a separate device tree repo is going to be very painful for people when they're not used to thinking that way.
Are we in a situation where we just need to do it now? Because it's going to be painful no matter what we do.
I don't think so. I think we should wait.
Okay. I think at least we need to create the mirror repo now.
Yes, let's do that.
Okay.
And let's put it on the horizon, but we're not there yet.
Okay, I need volunteers.
When we say move out of the kernel tree, does that include also PowerPC, MIPS, C6X?
Yes, everyone. But I do need one of the Zen folks, Ian, volunteered to. There you are. Yes, he's going to help me. I could use someone else to help manage this repo, and we need some scripts to make sure that this mirroring is automatic.
Or a small script.
Yeah.
So you're looking for one more volunteer, kind of have 3 people.
I think so.
Can we?
Okay.
There's enough.
Yeah, I have minions, yes. So I'll take an action to see if someone on our team.
Take an action to volunteer someone?
Yes.
Well, hold on. Is this a place where it would make sense to get maybe a non-ARM person?
Yes.
Like a PowerPC person?
Just to avoid monoculture? Yeah.
Yeah, that's a good idea. Yeah.
Scott. Yeah. What's that, Scott?
I can help as long as Grant doesn't go offline for 2 months at a time again.
It worked out so well last time.
So we'll take as an action also. Grant not to take 2 months off.
Stop going offline. Stop moving countries.
So we've got about 7 minutes until, well, lunch is probably already being served, so. Yes, we could get lunch before the crowds hit, so.
I still have one thing going back to the discussion of enforcing DT only builds for multi-platform. Now I've lost my. Wait. Yeah. So the idea that I have is that as soon as possible, the first step is that we mark everything that is not DT, that is not required for DT boot as ifdef config a tags or in the respective makefile syntax for that. Second step would be that we turn off config a tags by default in the multi-platform def config. Yep. And the third step, of course, would be to make config a tags depend on not multi-platform. Yep. And then if people really need it, they can edit the kconfig file until they have fixed their kernels.
We'll FedEx you some lunch.
Okay.
I'll go back to sleep then.
Yeah, thank you, Arnd. Good night. Anything else here? All right, thank you all very much.